In the last class, we have learned the basically moment of inertia tensor. This is L, and L can be written as I into omega. Please mind it, this I is not just a number, this is arrangement. So you cannot claim that this L will exactly have same direction of omega. This is not possible. But yes, sometime it can be possible when this I will be diagonalized. So let's go for one problem where this I can be diagonalized. So I am just taking a very simple problem. So let's say first we are just going to for the discrete charges. So obviously we have Ixx, it's nothing but summation over I mi yi square zi square, and similarly you have yy, you have zz, and we have product of inertia Ixy is equal to minus mi xi yi. And similarly, if you want to change this whole thing for the continuous system, you have to change this summation to integration. That is different issue. Today we are just first going to take a very simple problem, just a problem which is to understand the definition. So let us try to go for, this is my axis. Let us assume this is my origin O, and here is some mass m, here is some mass m, here is some mass m, here is some mass m. The coordinate of mass is a and a. This coordinate is minus a and a. This coordinate is minus a, and this coordinate is basically ये क्या हो जाएगा? A and minus a. ठीक है ना? This is minus a, ठीक है? These are coordinates. So these are xy coordinates. So this is x, this is y, and the whole system is rotated about y axis. ये पूरा का पूरा system y axis के about ये rotate कर रहा है with angular velocity omega, and omega is given as, let's say 0 omega, or let's say omega not 0. This is your omega vector. So what is my problem? My problem is that I have to calculate angular momentum of a system. मैं क्या calculate करना चाह रहा हूं? Just angular momentum of a system. So what I will do, I will just try to write the moment of inertia tensor. Then we will see how we can calculate this angular momentum of a system. Okay. So obviously this is in xy plane, but your moment of inertia will be always in 3 dimensions. ऐसा नहीं होगा कि अगर आप प्लेन में है तो उसे आप 2 डायमेंशन कंसीडर करोगे. Maybe some other term can be 0. Okay. But you have to write the 3 cross 3 matrix for the moment of inertia tensor. So by the inspection, we can say by inspection, just watching the symmetry, we can say there may be some term which can be exactly 0. What are these terms? Is that Ixz is equal to summation over minus mi xi zi. So this term is 0 because for every mass this z is 0. Yes.
Yes, sir.
Because it is in xy plane. So this is in xy plane, and we can rotate about y axis. The whole system is going to rotate about something like this. Okay. So obviously Ixz and Izx is equal to 0. What is the another term which is going to 0? Yz.
YZ.
Very good. So this is summation over mi yi, sorry, yz. Yz is equal to 0. Summation over mi ये क्या आ जाएगा? Yizi. This is also Izy. This is also 0. Now, so these 4 terms are 0. We can just say from the inspection. Inspection के through ही हम ये 4 term को 0 कर सकते हैं. ठीक है? Now we have to calculate the diagonal term and one off diagonal term. Another will be symmetric of this. So let's try to calculate Ix x. That is nothing but summation over mi yi square plus zi square. Very good. Summation over I. And for every mass, zi square is 0. So you have summation over mi, and this is yi square. So what is this value? Let us assume this is my first mass, this is my second mass, this is my third mass, this is my fourth mass. So let us try to go for this particular thing. So first mass is m into minus a square plus second mass is m into a square. What is third mass? M into a square. What is fourth mass?
M into minus
M into minus a square. So this is nothing 4 ma square. Okay. So this is your I ixx. Similarly, we can go for I yy. So if we are talking about Iyy, then also what is this particular thing? You can just go for summation over mi xi square plus zi square, and again zi square is 0. So we have summation over mi xi square. So what will happen to this particular thing? Mi xi square. Then this is again what? M into a square plus m into, पहले बार सारा लिखते हैं, कोई दिक्कत नहीं, a square plus m into minus a square plus m into minus a square. Okay. So again, this is 4 ma square. Great. So this is your 4 ma square. Now let's go for izz. So what is izz? Izz is basically
sigma mi
summation over I mi xi square plus yi square. So we can write summation over mi xi square plus summation over mi yi square. So mi xi square we have calculated 4 ma square, mi yi square we have calculated 4 ma square. So this is nothing but 8 ma square. Are you people comfortable?
Yes, sir.
Yes. So this is nothing but 8 ma square. And you can also see something like this is one theorem is also there, that is known as what? Perpendicular axis theorem. Isn't it? Iyy is equal to ixx plus izz is equal to ixx plus iyy. So this is something like this. Okay. Now one more term is there. What is this? ixy. जरा बताओ तो ixy की वैल्यू क्या होगी? पहला ले लेते हैं. That is minus m a into minus a, है ना? प्लस दूसरा वाला का क्या आएगा? माइनस m a into a प्लस तीसरे वाले का क्या आएगा? माइनस m
minus a into minus a.
माइनस m माइनस a into माइनस a. फोर्थ वाले का क्या आएगा? माइनस a into a. Okay. And fourth is that minus m, you have minus a into minus a. So I think every term is 0.
Yes, sir.
0 हो रहा है? Yes.
Yes, sir.
So this will be 0. We are just using this formula basically. We are using summation over mi xi yi with minus sign. This will be I xy, and this will be same thing I y x. Now we have calculated all these things, and let's try to go for our moment of inertia tensor. So you can see the moment of inertia tensor is 4 ma square 0 0 0 4 ma square 0 0 0 4 ma square, and this is your moment of inertia tensor.
8 ma square, sir.
Sorry, 8 ma
IZZ.
square. 8 ma square. Okay, this is 8 ma square. Now, let us try to calculate the angular momentum L. What is angular momentum? I into omega. So what is your I? I is equal to 4 ma square 0 0 0 4 ma square 0 0 0 8 ma square, and you have this omega as 0 omega naught 0. So what is this value? What is angular momentum? Your
4 ma
angular
square.
momentum is basically
4 ma square omega naught.
very good. So this will be 4 ma square 4 ma square omega naught. This is your angular momentum. Now you can calculate it into different way also. This is your axis, and the whole system is rotated about this particular axis. So if you will take the perpendicular distance for each mass, then you will get exactly same thing. इसका इस पॉइंट के अबाउट, इस एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया क्या होगा? ma स्क्वायर. यस, इसका भी क्या होगा? ma स्क्वायर. इसका भी क्या होगा? ma स्क्वायर. इसका भी ma स्क्वायर. So you will write first particle ma square into omega naught plus ma square into omega naught plus ma square into omega naught plus ma square into omega naught. So you have 4 ma square omega naught. You can easily calculate this thing. Now, how we can get this particular thing? Anna? Because we have seen that this is diagonal matrix. So if this is diagonal matrix, there is not any problem. Okay, there is not any problem. Okay, now what will happen if you are rotating about this axis? What should we answer?
सर मैट्रिक्स डायगोनल नहीं होती.
8 ma square.
क्या होगा?
8 ma square omega.
8 ma square omega naught. Yes,
Yes, sir.
because this is
Yes,
z
sir.
axis, and you have to calculate. Then this is your diagonal. This is your perpendicular distance, isn't it? With this axis. यही होगा ना?
Yes, sir.
So what will happen? M into 2a square. M into 2a square. M into 2a square. M into 2a square. You will have 8 ma square. Isn't it? What is this distance? Root 2a. 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 So you have all this distance root 2a, and you can easily calculate this particular thing. If I am talking about your moment of inertia about this axis, and this is your perpendicular distance, you can see this is perpendicular distance. Are you getting my point? And again, and then your omega is equal to basically that time 0 0 omega naught, and you can also get the same thing from here also. Now you are very lucky that this is a typical symmetric problem. This is a typical symmetric problem. Why? Because if you will change one mass to another mass, one mass to another mass, one mass to another mass, there is not any problem. The system will remain same. And hence your moment of inertia matrix is diagonal. Then you can only see this direction of omega will govern the direction of angular momentum. Isn't it?
Yes, sir.
Hence this moment of inertia tensor are symmetric in nature. Then only you can create this story. For example, अगर आपसे कोई पूछे कि this L is basically I into omega, and omega is in z cap direction, then it is very common thing that you will say that okay, the direction of L is in z direction. This is a very natural answer, but this is not actually correct. Let us try to do the same problem but we are changing the symmetry. हम लोग इस सिमेट्री को चेंज करते हैं, फिर देखते हैं हमारा ये प्रॉब्लम क्या होता है. Okay, are you people comfortable up to this?
Yes, sir.
Okay, so let's go for another problem and we are just going to change the symmetry. ठीक है? Okay, so let's go for different problem. So we have a same xy axis. This is my origin. Now we are just going to do the different problem. This is mass m. This is 0 and a. Okay. This is mass 2m. This is a and a. This is mass 3m. Then this is what? क्या हो जाएगा ये नेगेटिव रखे तो?
Minus a.
Minus a and a. And this is mass 4m. That is what?
Minus a.
Minus a and 0. है ना?
Yes,
This
sir.
is minus a and 0. So these are the conditions. Now you can see. This is x. This is y. And again this is rotated. The whole system is rotated with angular velocity omega in about y-axis, means omega is again given as 0, omega naught, 0. Okay. Now
sir.
let's हाँ बताओ.
सर वो जो स्मॉल मास है ना,
हाँ.
वो a0 होगा सर.
कौन वाला?
सर केवल m जो लिखा है आपने.
Oh, first वाला ना? Oh, sorry. This is a0. Thank you. a0. Okay. हाँ, this is a0. Okay, so let's try to go for this. Again, this is in xy plane. Okay, so if it is in xy plane and this is the instantaneous position, this is at the instantaneous position at this is in xy. At this particular instant, we have this kind of situation. Okay, so again I can say Iyz is equal to Izy is equal to 0 and Ixz is equal to Izx is equal to 0. कह सकते हैं? Because this is in xy plane. Okay. And now let us try to calculate Ixx. So you have summation over summation over I mi yi square plus zi square. What will happen? You can have summation over mi yi square. Okay, because zi is equal to 0. So let us go for first, second, third and fourth. So we have m into 0 square. Second is 2m into a square. Third is 3m into a square. Fourth is 4m into 0 square. So that is 7 ma square. So Ixx is 7 ma square. Let's go for Iyy. Mi xi square.
5m square.
Huh?
5m square.
5m होगा.
लास्ट वाला भी 0 आएगा.
5m a square.
Sorry, this will be what? 5 ma
5
square.
ma square. Yes, sir.
Oh, this is 5 ma square. Okay. 2 ma plus 3 ma. 5 ma square. Okay. ठीक है. Let's try to go for this. इसको देखते हैं क्या आता है. So again, zi is 0. We have summation over mi xi square. And then what you have? You have basically
m into a square.
m into a square, 2m into a square plus 3m into again a square plus 4m into 4m into minus a square है ना, 4m into minus and 3m into minus a square,
हाँ.
minus a square, but a square ही होगा. Okay, so is that okay?
Yes, sir.
Yes,
क्या आ
sir.
रहा है?
10 m square.
10 m
10 m square. This will be 10 m square. Okay, so this is your 10 m square. Now what will be IZZ?
10 mm square.
15 m square.
Summation over mi xi square plus yi square. So you can just go for summation over mi xi square plus summation over mi yi square. So what is this value?
15.
Xi square is 10 ma square
plus 5.
plus 5 ma square. That is what? 15 ma square. Okay, so this is your diagonal term, and we have also calculate one off diagonal term. So let us try to calculate that off diagonal term. What is going to happen for that thing? Now, so what will be I xy is equal to I yx is equal to minus summation over mi yi xi. दोनों में से कोई xi yi दोनों में से कोई ले लो. फर्स्ट वाला क्या होगा? माइनस m a इंटू 0 प्लस माइनस m
minus 2m, sir.
माइनस 2m ऑब्वियसली a इंटू a. ठीक है, थर्ड वाला क्या होगा?
Minus
प्लस
3
माइनस 3m माइनस a इंटू
a.
a. फोर्थ वाला माइनस 4m
plus 4.
माइनस
Sir,
4m
सही.
माइनस a इंटू 0. ठीक है ना?
Yes, sir.
So what will be this value?
Sir, m square.
ma square. So that value is ma square. Now you can see for this arrangement, my moment of inertia tensor is not a diagonal one. So what is my moment of inertia tensor? My इसको हटा दूं, यहां कर देता हूं, है ना? So my moment of inertia tensor, this arrangement can be written as I, that value is 5 ma square, ma square, ma square, 10 ma square, 0 0 0 0, and there is 15 ma square. And if we are going to calculate the angular momentum, then what is angular momentum? Angular momentum L is equal to I omega, and then we can easily calculate by multiplying with omega, and omega is also written in term of vectors. So this L can be written as 5 ma square 0, ma square 10 ma square 0 0 0 15 ma square, and there is 0 omega not 0. What is this value? So first
10 ma
term is
square.
what? First term is ma square
Ma square. Omega.
omega naught. Second term is what?
10 m square.
10 m square.
10 ma square omega naught. Third one is what? 0.
0.
And now you can see you have ma square omega naught outside. Your vector is 1 10 0. Obviously this is entirely different vector than this angular momentum, isn't it?
Yes, sir.
This is entirely different. Why it is not exactly? अब यहां पर क्या आप सेम प्रॉब्लम अगर यूज करो तो क्या आपका आंसर आएगा? नेवर। उस एक्सिस से परपेंडिकुलर डिस्टेंस लेकर के आप अगर काम करोगे, यू विल गेट दिस आंसर? नेवर। देन यू हैव ओनली वाई डायरेक्शन, और आपके पास सिर्फ यही आ पाएगा, इजंट इट?
Yes, sir.
है ना? सो ऑलवेज you have to keep in mind that how your whole inertia tensor is arranged with respect to origin. Obviously, if I will change the origin, then everything is going to change. You can do this problem again with this particular origin. Let's say, just do this homework and just post me what will be answer. This is m a minus a 2m a and a 3m a and sorry minus a and a 4m minus a minus a. Just try to calculate the moment of inertia tensor and just try to rotate omega as 0, omega not 0. Just try to rotate with this angular velocity. Let's see what you are getting. Are you getting the same thing or you are getting the different thing? Is that this is your diagonal term or off diagonal term? You have to just try to figure it out. But the whole idea is that when your mass is symmetric about your origin, then it's okay. Then it's okay. You can just use the first principle and you can calculate. But thing is that it is not always symmetric about the origin. The distribution can be different. Then obviously you have to use the whole arrangement with respect to that origin. And yes, the masses are same. So this is not a distribution of mass actually. जैसे सॉर्टन ने कहा था कि this is the distribution of mass. No, this is not a distribution of mass. This is distribution of moment of inertia. This is distribution of inertia about your origin. Now, just try to do this as your homework, and then you will see how we can change this particular moment of inertia tensor and all these things. Are you people comfortable up to this?
Yes, sir. Sir,
है ना? हाँ बोलो.
सर अगर origin center of mass से पास होते हुए जाता है तो स्टिल हमको नॉन डायगोनल टर्म्स मिलेंगे.
आपको फिर origin वहां लेना होगा. Just try to do this thing. Just try to
Okay.
figure it out.
Yes, sir.
Then what you have to do? Please देखो, it's a very good question. कि ये इनका कहना है कि सेंटर ऑफ मास से होता हुआ जाए. ठीक है, तो आपको इस पूरे सिस्टम का एक सेंटर ऑफ मास निकालना पड़ेगा.
Yes, sir.
ठीक है, अब उस सिस्टम के सेंटर ऑफ मास के रिस्पेक्ट में उसे ओरिजिन करोगे तो इसका क्या कोऑर्डिनेट होगा, इसका क्या कोऑर्डिनेट होगा, इसका क्या कोऑर्डिनेट होगा, इसका क्या कोऑर्डिनेट होगा, वो भी आपको निकालना पड़ेगा.
Yes, sir.
एंड दैट विल बी ह्यूज वर्क.
Right, sir.
आप ऐसे तो नहीं कर सकते हो ना. आपने जो कहा कि भाई चलो मेरा सेंटर ऑफ मास इधर ही कहीं पर मिलेगा, कुछ यहां मिला सेंटर ऑफ मास. ठीक है, अब ये मेरा सेंटर ऑफ मास है. देन यू हैव टू चूज दिस एज योर ओरिजिन. And after choosing this as your origin, you have to give the distance. What will be coordinate of this mass? 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 उन सारे मास का कोऑर्डिनेट लिखना पड़ेगा. And then you can apply this thing.
Yes, sir.
है ना? तब फिर आप इसको अप्लाई कर पाओगे. मैंने ट्राई नहीं किया है, बट इट्स अ वेरी नाइस क्वेश्चन. आई विल ट्राई इट. आप भी ट्राई करो कि अगर सेंटर ऑफ मास के अबाउट जा रहा है तो फिर क्या हो पाता है. ठीक है, बट
जी सर.
thing is that the moment of inertia tensor will change by the changing of origin. ठीक है, ये चीज
Yes,
हमें
sir.
दिमाग में रखना है. सो लेट्स गो फॉर, सो डिस्क्रीट सिस्टम में तो कोई प्रॉब्लम नहीं होनी चाहिए. जस्ट समेशन करना है ना. सो लेट्स गो फॉर मेनली वन प्रॉब्लम दैट विल बी फॉर द कंटिन्यूअस सिस्टम. कंटिन्यूअस सिस्टम को करते हैं, और आज की क्लास और कल की क्लास में हम लोग सिर्फ कंटिन्यूअस सिस्टम के बारे में बात करेंगे. Let us try to go for this problem. So first part आज करेंगे, बाकी कल करेंगे, है ना? So you have 0, 0, and let us assume this is your square lamina. Okay, x and y plane. This is your square lamina, and this length is a, and this length is a. I have just calculated for this square one. You can also go for the rectangular one. You can take this a, this b, but I am just going for a square one. Okay, या फिर इसके लिए कर दे, चलो इसी के लिए कर देते हैं. Let's go for rectangular lamina. This is b, this is a. Okay, this length is a, this length is b. The mass is distributed in xy plane, and this is continuous constant mass. Okay, they are constant mass. So let's try to figure it out. What will be moment of inertia tensor? And we want to just see what if the axis of rotation is from this origin, and this is given by 0, 0, omega naught. Okay, so this is your omega. Okay, this is your omega. Let's try to calculate this thing. Okay, so let's go for this. So again, can I say Ixz is equal to Izx is equal to 0? Yes,
Yes, sir.
because
Yes,
this
sir.
is in xy plane, and then Iyz is equal to Izzy is equal to 0. This is also 0. Okay, so let's try to go for Ixx. So Ixx is, now you have to go for integration dm y square plus z square. Again, z is equal to 0 for every given value of x and y. So this is dm y square. Now please tell me, this integration is single integration or double integration or triple integration?
Double integration, sir.
Double integration. Single integration किसने कहा?
सर मैंने कहा सर
क्यों single integration? Because y है?
डबल ही होगा सर, वो एरिया से
हम्म,
डबल ही होगा. मैंने वाई देखा था सर, इसलिए कह रहा
रावत है ना तुम?
हूं. यस सर,
थोड़ा धीरे हो जाओ,
सॉरी सर.
ठीक है? देखो, जिंदगी में अगर कुछ चाहिए तो ठहराव बहुत ज्यादा इंपॉर्टेंट है.
यस सर.
ठीक है, फास्ट जाने की जरूरत नहीं है. देखो, समझो, सीखो, फिर रिस्पॉन्ड करो. रिएक्ट नहीं करना है, रिस्पॉन्ड करना है.
ओके सर.
ओके, देयर आर डिफरेंस बिटवीन रिस्पॉन्ड एंड रिएक्ट. ठीक है?
ओके सर.
ओके, अगर लेजेंड बनना है तो रिस्पॉन्ड करना सीखो. ठीक है?
ठीक है सर, थैंक यू.
Okay. Now, this dm is obviously in the xy plane. ये जो dm है वो कहां पर है? वो xy plane में. So obviously this mass is distributed in xy plane. So this integral is not a single integral. This integral is actually double integral. So how you can write? dm upon dx into dy can be written as m upon a into b. क्या लिख सकते हैं इसे? Because density is uniform density है. लिख सकते हैं इसे, है ना?
Sir.
कोई भी एक आप छोटा सा पार्ट ले लो, इसको कर दो dm, और ये है आपका dx, ये आपका dy. तो ये इसका जो डेंसिटी होगा वो पूरे का डेंसिटी होगा, तभी तो यूनिफॉर्म है ना? हो सकता है कि ये x के साथ चेंज भी करे, x हो सकता है y के साथ चेंज भी करे. इस बार जैम के एग्जाम में आया था ऐसा प्रॉब्लम, है ना? बट थिंग इज दैट अभी हम लोग कांस्टेंट के साथ काम कर रहे हैं. सो m अपॉन ab. सो व्हाट आई कैन डू, आई कैन राइट dm एज m अपॉन ab dx into dy. So now you can see this is nothing but double integral, and if it is double integral, then I can go for Ixx is equal to, let's go take m upon ab integration dx 0 to a, and what about dy? Y
0 to
square dy 0 to b. So what is this value? M b square
by
by
3.
3. So this value is mb square by 3. So from the symmetry, what is value of I yy? बिना कैलकुलेट किए लिख सकते हैं।
m
ए
a
चुप
square
रहो,
by
तुम शांत रहो, दूसरे को बोलने दो।
जी सर,
ठीक है,
जी सर।
बताओ क्या होगा।
सर m a square by 3.
वेरी गुड, एम ए स्क्वायर बाई 3। आप क्या कैलकुलेट करोगे, dm x square plus z square and z is equal to 0. Again you will go for dm x square. You will use the same concept and I think you can get ma square by 3. Now what will be izz? बताओ। dm x square plus y square. So this value is obviously dm x square, ये कैलकुलेट कर चुके हो, dm y square ये भी कैलकुलेट कर चुका है, and it is more, and this is just in a plane, so you can easily use perpendicular axis theorem, है ना, and this will be m by 3 a square plus b square, ठीक है ना, m by 3 a square plus b square. So this is your I z z. Now एक टर्म बच गया, कौन सा टर्म बचा है, I x y and I y x. Both will be same because it is always a symmetric matrix. So if this is a symmetric matrix, then we have to calculate I x y is equal to I y x. That value is dm x y. कुछ गलती किया हूं क्या,
माइनस है,
माइनस साइन, ये मत छोड़ना, है ना। सो अगेन यू विल जस्ट यूज दैट दिस dm, एक बार dm निकाल लो फिर प्रॉब्लम नहीं है, m upon ab and you will take minus sign and you have x dx y dy, x की वैल्यू 0 से a, y की वैल्यू 0 to b. So I think minus m ab by 4, ठीक है, सही क्या हूं, yes.
Yes sir.
yes, sir.
Okay, so this is your moment of inertia tensor. Now we have calculated all the component and we can easily write this particular moment of inertia tensor. So what is my moment of inertia tensor? This will be Ixx mb square by 3 minus mab by 4 0 minus m ab by 4 m a square by 3 0 0 0 m a square plus b square by 3, ठीक है। नाउ अगर z एक्सिस के साथ जाएगा, व्हाट विल बी योर आंसर, सपोज इसके साथ जा रहा है, व्हाट विल बी योर एंगुलर मोमेंटम,
m by 3 a square
A
plus
square
b
plus
square
b
m by 3
omega
a square plus b square into
omega naught.
ओमेगा नॉट। इसको हम लोग दूसरे टर्म से भी निकाल सकते हैं, ठीक है, दूसरे डायरेक्शन से भी, दूसरे तरीके से भी निकाल सकते हैं, ठीक है।
Yes sir.
नाउ ओके, सो दिस इज योर एंगुलर मोमेंटम। लेकिन अगर ये हो जाए तो क्या होगा, ये तो देख रहे हो कि ये जेड की डायरेक्शन में है और जेड की डायरेक्शन में मिला ना तुम्हें, यस
yes
sir.
लेकिन अगर मैं ये दे दूं तो क्या आ रहा है, अब जरा बताओ,
Minus mab by 4 plus
क्या आ रहा है,
sir minus mab by 4 and ma square by 3.
माइनस mab by 4 m
a
a
square
square by 3
0
and 0 into omega naught, है ना, ठीक है। नाउ यू कैन सी दिस इज नॉट इन y डायरेक्शन, वाई, जेड वाले के साथ तो जेड के डायरेक्शन में था, लेकिन ये y डायरेक्शन में नहीं है, क्यों,
110 direct.
हाँ 110 डायरेक्शन तो सबको नजर आ रहा है, 11 नहीं है, वेट भी अलग अलग है, ठीक है, बट ऑब्वियसली नॉट इन y डायरेक्शन, वॉट एवर बी द नंबर, बट नॉट इन y डायरेक्शन। Why?
सर क्रॉस टर्म नहीं आ रहे थे.
I मैट्रिक्स के लिए.
You can see about z axis. अगर आप z axis के बारे में बात कर रहे हो तो उसके जो दिस इज इन द ब्लॉक डायगोनल फॉर्म. आर यू गेटिंग दिस थिंग? अब चूंकि ये ब्लॉक किसके अबाउट ब्लॉक डायगोनल फॉर्म में है, इसके अबाउट ब्लॉक डायगोनल. ये एक ब्लॉक है और ये दूसरा ब्लॉक है. ठीक है. एक्चुअली अबाउट z एक्सिस इट इज डायगोनलाइज. अगर z एक्सिस के लिए पूरे मैट्रिक्स को देख रहे हो तो ये पूरा डायगोनलाइज है. लेकिन अगर y एक्सिस के लिए देख रहे हो तो दिस इज नॉट डायगोनलाइज, इजंट इट?
यस सर.
There is xy component, there is xy component. So why it has some different rule. लेकिन z axis के about आप देखोगे, so obviously only this part is there. These two are contributing into that. It will just say that this will be in z cap direction. So you cannot predict the thing unless until you will not see the symmetry. Okay. And this is all about beautiful part of moment of inertia. So you look at, if you know the origin and if you know the omega vector, you can find the angular momentum about any arbitrary axis. किसी एक आर्बिट एक्सिस के अबाउट आपका एंगुलर मोमेंटम आप निकाल सकते हो अगर आप मोमेंट ऑफ इनर्शिया टेंसर जानते हो तो. It is not possible from the parallel axis theorem and perpendicular axis theorem in general. आप पैरेलल एक्सिस या परपेंडिकुलर एक्सिस थ्योरम सिर्फ इसके अबाउट लगा सकते थे. मैं जब +2 वाले प्रॉब्लम करूंगा तो मैं दिखाऊंगा कि मैं इसके अबाउट लगा रहा हूं तो मेरा सही आ रहा है. लेकिन इसके अबाउट लगाओगे देन यू विल रॉन्ग आंसर. आर यू गेटिंग माय पॉइंट?
यस सर.
So why this is important thing. Okay. Getting moment of inertia about this axis is entirely different thing. Getting angular momentum about this axis is entirely different thing. Are you getting my point? If I am asking you that what will be moment of inertia about this axis, then what will be answer?
ma square omega.
What will be moment of inertia about this axis? What will be answer?
So ma
IYY.
IYY. Yes, that will be IYY.
yes sir.
Okay. But if I am saying that the whole system is rotating about this axis, then only IYY is not going to contribute here. Are you getting my point?
Yes sir.
And this is going to contribute here. Ma square, this is going to contribute. But hence some part of y is also there. Here is also some part of y here. Isn't it?
Yes sir.
Yes
Sir.
sir.
So why it is also contributing? Are you getting my point?
Yes. और सर नहीं होगा तो फिर नहीं आएगा सर.
If it is diagonal, अगर ये diagonal matrix होता तो क्या होता? ये वाला पार्ट 0 हो जाता.
Yes sir.
है ना? तो फिर इसका कोई रोल नहीं रहता, ओनली इसी का रोल रहता.
Okay sir.
जैसे कि जेड एक्सिस वाले में देखो,
Sir.
सिर्फ इसी का रोल नजर आ रहा है. आर यू गेटिंग माय पॉइंट?
Yes sir.
Yes sir.
थोड़ा सोचने की कोशिश करो क्या हो रहा है. ओके. किस तरह से, अगर आप इसी प्रॉब्लम को मैं कुछ इस तरह से दूं, और ये मैं स्क्वायर बना दूं, तो आप देखो क्या होता है. And this will be from -a to +a. This will be again from -a to +a. और -a/2 to +a/2 कर लो. -a/2 एक a का स्क्वायर बना लो. और सेंटर पर ऑरिजिन है. Then try to see what is going to happen.
Diagonal.
You will
Only
see that will be diagonal, क्योंकि इसको आप रोटेट भी कर दोगे तो सेम ही चीज नजर आएगा तुम्हें. x को y से चेंज कर दो, y को x से चेंज कर दो, you will get the same thing. Isn't it?
Yes sir.
है ना? और ऑफ डायगोनल टर्म को अगर आप कैलकुलेट करोगे तो क्या होगा, एम ए बी ए तो सेम रहेगा, and you will get from minus a by 2 to plus a by 2 x dx. That value is what? 0. Minus a by 2 to plus a by 2 y dy. What is this value? This value is itself 0. Isn't it?
Yes.
यस सर।
तो वो वैल्यू अपने आप 0 हो जा रहा है, तो आपको क्या मिलेगा? ओनली यू हैव डायगोनल मैट्रिक्स। और जब आपका डायगोनल मैट्रिक्स मिलेगा तो उसमें सिर्फ और सिर्फ y एक्सिस के अबाउट ये वाला पार्ट ही कंट्रीब्यूट होगा, x एक्सिस के अबाउट ये वाला पार्ट ही कंट्रीब्यूट होगा, z एक्सिस के अबाउट ये वाला पार्ट ही कंट्रीब्यूट होगा। सो थिंग इज दैट वेयर इज योर चॉइस ऑफ ओरिजिन? आपका ओरिजिन कहां पर है, ये बड़ा इंपॉर्टेंट पॉइंट है, एंड दैट इज वन कोऑर्डिनेट। किस पॉइंट पर आप ओरिजिन रख रहे हो, दिस इज वेरी इंटरेस्टिंग। और आपके एक्सिस कैसे है? ओके अगर ये प्रिंसिपल एक्सिस रहता तो 100% ये क्या होता, दैट विल बी डायगोनलाइज इन नेचर। तो आपके लिए कोई काम बहुत ही ज्यादा आसान हो जाता। ओके सो आज के लिए इतना ही रहने देते हैं। सो नेक्स्ट, हाँ बताओ।
मुझे एक चीज पूछनी है, जैसे आपने कहा कि सिर्फ वाई डायरेक्शन में मतलब प्योरली होने के लिए उसकी टॉप वाली टर्म और लेफ्ट वाली टर्म 0 होनी चाहिए।
नहीं क्वेश्चन पहले ठीक से फ्रेम करो, क्वेश्चन समझ नहीं पा रहा हूं मैं।
सर जो